everybody, today's practice problem comes from Principles of Microeconomics by Dirk Mateer and Lee Kopic. We're going to be doing chapter 6, problem number 2. The problem begins with the following information. A cash-starved town decides to impose a $6 excise tax on t-shirts sold. The following table shows the quantity demanded and the quantity supplied at various prices. And then we're given this information here. So we can see here we're getting demand and supply that behaves like we would expect, because as the price is getting lower, our quantity demanded is going up. And as our price gets lower, our quantity supplied is going down, meaning that supply or quantity supplied is higher at higher prices, and vice versa for demand. So if we were to plot these points, we would get a supply curve and a demand curve that look like what we've been talking about. But let's think about how we can do this problem directly by just using this information in the table. So the first part of the problem asks, what are the equilibrium quantity demanded and the quantity supplied before the tax is implemented? And then it wants us to determine the consumer and producer surplus before the tax. So let's think about what our market equilibrium is, or how that's defined before we have this tax in place. So if we don't have a tax, then let's think about the relationship between what the consumer pays for the t-shirt and what the producer actually gets to keep for the t-shirt. Well, those are just going to be the same number, right? That's just going to be our market price, because there's no friction in that market. There's no revenue or no part of that selling price going to a third party. So we could say here, before the tax, that the price that the producer gets to keep is the same as the price that the consumer pays. And sometimes you see this as supply price, because the producer is the supply side, and demand price, since the consumer is the demand side. And sometimes you see this, the price net of the tax and the price including the tax. Regardless of how it's stated, the concept is still the same. So we say that these two prices are the same. Let's just call that, that was our P star that we've been talking about. And the condition for an equilibrium is, of course, that the market quantity supplied is equal to the market quantity demanded, which is what we've just been calling Q star. So what that means is that before the tax is implemented, we just have to go and find the price where quantity demanded and quantity supplied are equal. So we can just look here and we can say, oh, I noticed that at a price of $10, my market is demanding 30 t-shirts, but my market is also supplying 30 t-shirts. So that's actually going to be our equilibrium price. So we can just say here that this guy is equal to $10, and our market quantity is equal to 30. Now the next step is we want to understand what our consumer surplus and what our producer surplus is. Now, again, if you're given the information like this, you want to think about how to just use this information rather than try to sort of shoehorn this into a demand curve and then try to figure out what that triangle looks like, etc., etc. Just take the information as given. Okay? So let's think about consumer surplus here. We can say that there were 10 consumers willing to pay $16 for a t-shirt that only got charged $10, right? Notice I didn't start at the top here, simply because there were no consumers willing to pay $19. But I guess if you wanted to be totally accurate, you could say, okay, well, let's start at this very top, that we have 0 consumers getting a surplus of 19 minus 10, and so on and so forth, right? So again, consumer surplus is just that amount by which the consumer's valuation, or the consumer's willingness to pay, exceeds the price that's actually charged in the market, in this case $10. So we could do the following. We could say, this is kind of irrelevant, but we have 0 customers that if they were actually customers, they would have each gotten surplus of 19 minus 10 on these t-shirts. And that's just going to be 0. But we can continue this logic and we have 10 customers here that are willing to pay 16 that are actually paying 10. And we can see that the demand curve, or the quantity demanded, is actually giving us some measure of what we can call marginal willingness to pay. Because if all of a sudden, at a price of $16, 10 consumers enter the market, we can infer from that that those 10 consumers were willing to pay up to $16 for this t-shirt, right? So here we could say that there were 10 consumers that were willing to pay $16, still only paid $10. Now be careful with this next one, because there were a total of 20 units demanded at a price of $13. But that doesn't actually mean that 20 consumers had a willingness to pay of $13. Because check this out. This 20 quantity demanded at a price of 13 already includes these 10 guys, right? So what we're really seeing is that at a price of $13, we had 10 more customers come into the market. So we actually have counted in this 20, 10 consumers who are willing to pay 16 and 10 who are willing to pay 13. Nonetheless, we have an additional 10 consumers who were willing to pay 13 and actually only paid 10. And then we have this last group of consumers here who entered the market when the price dropped to $10. So we can infer that their willingness to pay was $10. And we got 10 additional consumers. Now, unfortunately for these consumers, they're not actually getting any surplus because they're being charged their entire willingness to pay. But we can add them in for the sake of completeness. So you can say plus 10 times 10 minus 10. I know I haven't been consistent with my multiplication notation, but hopefully you see what's going on here. And if we were to add all this up, because we're calculating the consumer surplus for the entire market, not just for one individual, we'd say, well, this is 0. This is 6 times 10, which is 60. This is 3 times 10, which is 30. And this is 10 times 0, which is just 0. So we get a total of $90 of consumer surplus. The approach we can take for producer surplus largely follows that same pattern, albeit in a different context. So let's think about what we have going on with our suppliers here. So we have this quantity supplied, but we said that the supply curve actually represents willingness to sell. So you can think about these price numbers as representing a form of marginal willingness to sell. And we can use largely similar logic that we did to figure out the consumer surplus. Because what we notice here, if we're looking at the supply curve, we have 10 units the producers were willing to sell at $4. When the price rose to $7, producers were willing to supply a total of 20 units. That would imply that they're willing to sell an extra 10 units above and beyond those that they were willing to sell for $4 once the price hit $7, and so on and so forth. That each time the price increases to one of these points, we get an additional 10 units of supply. So we can think about here, well, again, we have producer surplus. And producer surplus is just the amount by which the price that the producer actually receives exceeds the minimum that the producer would have sold at, or the actual price minus willingness to sell, or, as we'll see, the actual price minus marginal cost. So here, we, rather than starting at the highest price and working down, like we did with consumer surplus, what we can do instead might be helpful to think about starting at this lowest price and working our way up. And again, we stop once we hit that market price because that's where the units stop getting transacted and we can't get any surplus on units that aren't bought and sold. So anyway, we can say that there are 10 units being sold that would have been sold at a price of $4, but are actually being sold at $10. So that generates producer surplus of 10 times 10 minus 4. Easy enough. We can continue this and we can say, well, once the price goes up to 7, an additional 10 units of supply entered our market. So there were 10 units of supply that had a willingness to sell of $7. So the producer surplus on those is going to be those 10 units times the actual price of $10 minus the willingness to sell of $7. We can keep doing that. And we notice now we hit our market price of $10. We get an additional 10 units of supply once again, but we're not getting any surplus on those because the market is actually at the same price as the willingness to sell. But again, we could still add it in, and we could say we could add in that last 10 units of supply, but then there's really no price above and beyond the willingness to sell, and this is just going to be 10 minus 10, which is 0. And we can add this up, and we can say, well, this is just equal to 10 times 6, which is 60, plus 10 times 3, which is 30, plus 10 times 0, which is 0, for, again, $90 of surplus. You notice a few things. One, consumer surplus and producer surplus are usually measured in dollars. And in this particular case, we see that consumers and producers, at least before the tax is enacted, get the same amount of surplus. The next part of the problem asks us what the world looks like once we put this tax in place. So it says, what are the equilibrium quantity demanded and the quantity supplied after the tax is implemented determine the consumer and producer surplus after the tax? So just as a reminder, if we go back to the initial part of the problem, we see that the amount of the tax, which I'll call T, was $6. So there was a $6 tax on t-shirts. And we can also think about what is our condition for equilibrium once we have this tax in place. And if you think about it, what this tax is actually doing is it's driving a wedge between the price that the consumer pays inclusive of the tax and the price that the producer receives net of the tax. That all of a sudden those two prices have to differ, not surprisingly, by the amount of the tax. So now we don't have this single P star. What we have instead is we have a condition where the price that the consumer pays inclusive of the tax is going to be what goes to the producer, call it P sub P, plus the amount of the tax, which in this case is $6. Just put 6 here. So we have to find the point where prices are apart by the amount of the tax to the producer and the consumer, but still where quantity supplied is equal to quantity demanded. So we can still say we're looking for this point, and I'll just call this Q star sub T for tax. So we can think about how to do that over here. And we can say, well, we're looking for a price that's $6 higher for the consumer. The consumer is the demand side of things here, than it is for the producer, or the supply side. But where the quantity demanded and quantity supplied are the same. So if we were to think about what that means as we're going through, we need numbers where the price in the demand row, the demand row is 2 rows above the supply row because that's where the prices are off by $6. So we could say here, well, do things line up here? Do they line up here? Do they line up here? And so on and so forth. And what we see, if the consumer was paying $19, they wouldn't be demanding anything. The producer would be getting $13, and he'd be supplying 40 t-shirts. That's not an equilibrium. If the consumer was paying $16, he'd be demanding 10 units. The producer would be getting $10. He'd be supplying 30 units. Not an equilibrium. If the consumer was paying $13, they would be demanding 20 t-shirts. The producer would be getting $7, and he'd be supplying 20 t-shirts. Oh, hey, look, that's where our condition for equilibrium is actually satisfied. So what this means is that in this equilibrium, our price to the consumer is equal to $13. Our price to the producer, not surprisingly, is $6 below that, at $7. And our equilibrium quantity with our tax, which is the quantity that corresponds to either one of those points, which is a quantity of 20. So not surprisingly, we see that this is in line with what we see graphically when we look at taxes. We say that when we put a tax in place and we have an upward sloping supply curve and a downward sloping demand curve, the consumer and producer share the burden of the tax. That the price to the consumer doesn't go up by the full amount of the tax, and the price to the producer doesn't go down by the full amount of the tax either. It's kind of shared. And that's what we're seeing here, because we're comparing this to an original equilibrium price of $10. So what we see is the consumer ends up paying $3 more, and the producer ends up getting $3 less. The other thing we note is that when we have upward sloping supply and downward sloping demand, a tax reduces the quantity bought and sold in the market. And again, that's what we're seeing, because we're buying and selling 20 t-shirts as opposed to 30 like we were before. So now let's calculate consumer surplus and producer surplus again. So we'll start with consumer surplus. So you just say CS. And again, the procedure is exactly the same. But what has changed now is the market price and also the quantity transacted. So we can say, well, there were 0 customers willing to pay $19, so there were 0 customers getting a surplus of 19 minus the price that's relevant for the consumer, which is now 13. We had 10 customers who were willing to pay 16, and now they're willing to pay 16 and only actually paying 13. So they get surplus of, there's 10 of them, so 10 times 16 minus 13. And then this last group of consumers that's consuming, this additional 10 consumers, or this marginal 10 consumers, and going from 10 to 20 quantity demanded, they're getting charged their entire willingness to pay because the consumer's price is now $13. So we could say here, plus 10 times 13 minus 13. And if we were to add this all up, we just get 0 plus 10 times 3, which is 30, plus 10 times 0, which is 0. We just get $30 of consumer surplus. And not surprisingly, we get consumer surplus that's less than the original consumer surplus of $90, because taxes tend to reduce consumer surplus. So now let's do the same thing for producers. We can say, all right, producer surplus. And again, this time we start at the bottom. And we said there were 10 units of supply that would have been sold at a price of $4, willingness to sell of $4. Let's compare that to the price that the producer actually received, which is $7. Say, well, that's going to be surplus of 10 units times the actual price, 7, minus that minimum willingness to sell, which was 4, plus, well, we had an additional 10 units here, going from a supply of 10 to a supply of 20, where the willingness to sell was 7, and the price that they're actually getting is 7. So this is going to be an additional 10 units, but on each of those units, there's actually 0 surplus generated, because this is just going to be 7 minus 7. And if we put this together, we get 10 times 3, which is 30, plus 0, which is just $30 of producer surplus. So we can see again, as taxes tend to do, our producer surplus is lower under the tax than it was without the tax. And for both consumer and producer surplus, the surplus is going down for two reasons. One, less surplus is generated on each unit transacted because of the higher price to consumers and the lower price to producers. But two, there are fewer units actually being transacted. The last part of the question asks, how much tax revenue does the town generate from the tax? So we can think about how to calculate this. Well, we said that the amount of the tax was $6. Put it somewhere here. Here we go. T equals $6. So the government's collecting $6 on every unit that's actually bought and sold after the tax is put in place. So we could say, for example, the government revenue is equal to the per unit amount of the tax times however many units are bought and sold once the tax is put in place, which is what we just denoted as Q star sub T. It's important to remember that the government can only collect revenue on units that are still being bought and sold after the tax. So make sure you multiply by this new equilibrium quantity and not by this original equilibrium quantity here, because if we're not buying or selling all 30 of those units, the government can't collect revenue on all 30 of those units. So here we could just plug in these numbers, and we can say that this is going to be $6 times our equilibrium quantity with the tax, which was 20. The government is collecting $120 from this tax. And we can see again, government revenue is measured in dollars. So that technically completes what we were asked in the question, but let's think about one more thing that's helpful. So what we noticed here is that when the tax was put in place, consumer surplus went down by $60. Producer surplus also went down by $60. So consumers and producers collectively lost $120 of surplus when this tax was put in place. In this particular example, all $120 of that lost surplus is actually made up in government revenue. That's not generally going to be the case. Usually the case is that the drop in collective consumer and producer surplus ends up being larger than the amount collected in government revenue, which is why economists can say that taxes create, in a lot of cases, when they're placed on otherwise well-functioning markets, they create what's called deadweight loss, or economic inefficiency, because the losses to producers and consumers are not completely made up for by the gains in terms of government revenue.